Welcome you all. Myself, Suresh Kumar, Assistant Professor, Department of Mechanical Engineering. Today, I'm going to teach about the topics chip formation and types of chips in metal cutting and machine tools course. So at the end of the session, we'll able to understand chip formation, how chip formed in single point cutting tool and types of chips and types of chip breakers. So here we can observe a flat surface, flat workpiece. Here we have a single point cutting tool. So this type of operation we can observe in shaper. So here the figure represents an orthogonal cutting. It is a presentation of a shaping operation in which the workpiece remains stationary and a tool advances into workpiece towards the left. Thus, the metal in front of the tool gets compressed very severely, causing the shear stress. This shear stress maximum along the plane called shear plane. So if the material of the workpiece is ductile, the material flows plastically along the shear plane, forming the chip which flows upward along the face of the tool. Here it is a chip flows along the face of the tool. So the chips are depends on work material and nature of workpiece we are using for machining, and geometry and material of the cutting tool, level of cutting velocity and feed rate, machining environment and cutting fluid, dimension of the tool, and friction between tool and workpiece. Here we have three types of chip forms. First one, continuous chip, discontinuous chip, and built up chip. Here we can observe after cutting tool, here we can observe a build-up edge on the workpiece. So let us see one by one. First one, continuous chip. So in this type, generally we can observe in ductile materials. So this type of chip is produced during the emission of ductile materials like mild steel under favorable cutting conditions, such as high speed and minimum friction. Let us say, so this type of we can observe in high speed like a finishing cuts and between chips and tool face. So it will breaks the chip, and chip tool interface can minimize the polishing the tool face and use coolant. So in this process, the chip moving smoothly up the tool face. So here we can observe, here it is a tool and the tool moves up. The chip flows along the face of the tool. So what are the advantages of continuous chip? Here the rake angle is high and cutting speed is very high. By using this continuous chip process, we can observe good surface finish and less friction between chips and tool. Next one, continuous chip. So this type of chip formation we can observe in the brittle materials like a bronze, cast iron, like that. So these chips are produced in the form of small segments as shown in figure. So in machining such materials, the tool advances forward, the shear plane angle gradually reduces until the value of compressive stress acting on the shear plane becomes too low to prevent the rupture between chip and tool. So such chips are also sometimes produced in the machining of ductile materials. When low cutting speeds are achieved and there is no lubricants we are providing, at that time we can observe this type of chips in ductile materials also. So due to this, the friction between chip and tool is very high. A chip into small segments. Here we can observe the chip is separated into small parts. The wear of work tool nothing but a tool. So wearing of tool is very high, poor surface finish, and here we are providing a small rectangle on this tool. So too much of depth of cut we can provide. Next one, chips with build-up edge. So in this figure, we can observe build-up edge on the workpiece. So these chips are usually formed while machining a ductile material when high friction exists on the chip to tool interface. The upward flowing chip exerts pressure on the tool face. The normal reaction, here we can observe the normal reaction between the chip and tool face is quite high. So maximum at the cutting edge. So here we can observe the cutting edge. So here the curve represents the maximum at this point. So this gives the raise to high temperature and compressed metal adjacent to nose gets welded on it. The extra metal welded to the nose or point of tool called build-up edge. So this metal is highly strain hardened and brittle with the result. As the chip flow up to the tool, the build-up edge is broken and carried away with the chip. So due to this rough finish on the workpiece, vibrations in cutting tool, and low cutting speeds, small rectangle, we can observe this type of chips with build-up edge. Generally, we are not preferring chips with build-up edge because due to this, we can obtain a very poor surface finish product. Next topic, chip breakers. So chip breakers in the sense, we are providing an additional edge on the cutting tool in order to cut the continuous chips. So here we can observe two types of grooves on the tool. Here it is a curved surface. Here we can provide a V-shaped groove to cut the continuous chips. So chip breaker may be defined as a modification of the tool face in order to control and break up the chips. So when high-speed steel tools are used for cutting under low RPM, continuous chips are formed. So in this case, by using chip breakers, long chips are broken into small pieces are formed. So chip breakers break the produce chips into small pieces. So these are provided to control the continuous rubbing between chips and tool. So the chip breaker deflects the chip at a sharp angle, causes it to break the small pieces. So here we can observe the different shapes of grooves which is provided on the work tool. So here it is a groove type. Here we can provide a shape type. So like just like a step. So in the before figure, we can observe here also V groove type. And here we are providing additional rake angle. So here we are providing additional rake angle in order to cut the excess chips. So here also here it is a tool. Above the tool, we are providing a chip breaker as a small piece, so which is clamped by using additional clamper. So in this topic, we have small questions as well as long answers questions. So how the chips are formed and long answers, explain the types of chips and explain the chip breakers. So that's all for today's class. Thank you.